Today we're going to be talking about equations of lines. And back in Algebra 1, you learned a couple forms of equations of a line. And we're going to talk about two of them today. The first one is called slope-intercept form. And slope-intercept form is useful when you have the slope, which m is for slope, and b is the y-intercept. And that's why they call it slope-intercept form. You have your slope and you have your y-intercept. Now, in some instances, you're not given the y-intercept. Instead, you're giving a point and a slope. And in that instance, there's another form called point-slope form, where m is, again, the slope, and the coordinates x1 and y1 are the coordinates of the given point. So you see your equations here in slope-intercept form. M is your slope. Oops. And y is your, or sorry, b is your y-intercept. Here we go. And in point-slope form, m is also your slope, and that x1 and y1 are the coordinates of the point that you are given. And we're used to labeling points x1 and y1 when we do the distance, slope, and midpoint formula. So this shouldn't be too much of an issue. And then I just want to note that we have subtraction signs. So depending on what information we're given, sometimes slope-intercept is better, sometimes point-slope is better, and we'll talk about why. So here, write an equation of a line in slope-intercept form. Remember, we talked about how to count slope. So if we count slope, we're going down 3 and right 5. So your slope, or your m, is -3/5. Your y-intercept. The y-intercept is where you cross the y-axis. Here's the y-axis. We cross it right here, and the y-coordinate there is 3. So my y-intercept is 0, 3. So b is equal to 3. Now the equation is y equals mx plus b. We know what m is, and we know what b is, so we can substitute those in. Y equals -3/5x plus 3. And that is our final answer. We don't need to do anything more. That's the equation of the line. So now, if we're only given 2 points and we try to write in slope-intercept form, it's going to be a little bit more work, and I'm going to show you why that is. So the slope, we have to calculate the slope first using the slope formula, because we don't know what the slope is. It's not like up here where we could count the slope. We have to do that formula. So y2 minus y1, so -4 minus 7, over x2, 6, minus x1, which is 4. So -4 minus 7 is -11, over 6 minus 4 is 2. All right, so now we have our slope, where m is -11/2. Well, now we have to plug that into y equals mx plus b using one of the points. And I'm going to use positive points. So x and y, our equation for slope-intercept form is y equals mx plus b. If I know what y is, 7, we know what m is, -11/2 from back here, times 4, which is x, plus b. So let me just highlight those things where I got those from. Then yellow for x. And let's do light blue for our slope. So you can see I just plug those things in, and now I can get b by itself. All right, so to do that, we have to do 7 equals negative 11 over 2 times 4 is negative 44 over 2 plus b. 7 equals negative 44 divided by 2 is negative 22. And then add 22 to both sides. We get 29 is equal to b. So now we can write our final equation, y equals negative 11 over 2x plus 29. And that would be our equation in slope-intercept form. And that was a pretty long process to do. So I don't like to do that like any of the time. It just seems like a lot of work when we have a better tool. But you could always do this, and it will give you the correct equation of a line. It just doesn't always, it's not the most efficient. And you can see that it's not always the most efficient because we have fractions to deal with, and then we're multiplying by fractions, and it can just get really messy. So let's do another one, but instead, point slope form. We still have to calculate the slope between x1 and y1, and x2 and y2. Okay. So we're still going to calculate the slope. So m equals negative 4 minus 12 over 6 minus 8. Okay, that's going to be negative 16 over negative 2, or positive 8. Now, point slope form is y minus y1 equals m times x minus x1. We know what m is. M is 8. That's our slope. x1 and y1 are points. Now, we have 2 points we can choose from. I always suggest using the point with only positive numbers if that's available. So I'm going to use these values for my x1 and y1. So now it's going to be y minus y1, which is 12, equals our slope m, which is 8, times x minus x1, which is also 8. And the beautiful thing is, this is it. We're done. That's our answer. We didn't have to multiply anything out. We didn't have to simplify. Because we were asked to write it in point slope form, this is all we have to do. Now, if you were given freedom to choose a method, then you might want to see what you're given. Like I said, if you're given a slope and an intercept and a y-intercept, I would always use slope-intercept form to get your equation. If you're given just 2 points, then I would use point slope form. Or if you're given a point and a slope, I would use point slope form. So example number 4, graph this equation in slope. We're going to graph that, but also write it in slope-intercept form. This means you have to get y by itself. So to get y by itself, first we're going to subtract 2x from both sides. So then that's going to give us negative 3y equals negative 2x minus 12. And then we have to divide everything by negative 3. So we get y equals 2 over 3x plus 4. Now that y is by itself, we can say that our y-intercept is going to be 0, 4. Notice we're going up by 2's. Now our slope is 2 over 3, so we're going to go up 2 and right 3. And we can go down 2 and left 3. And again, my x and y scale is going by 2's. So even though I went up 1 block, that really counted for 2 units. So my line is going to look like this. Then example number 5 down here. 2 people go outside to exercise. Find the rate at which each person exercise in miles per minute. We talked about slope being the rate of change. So what I would do is just count and see, all right, from 0, 0 to this point, 20, 4, what is your slope? Well, we went up 20, sorry, we went up 4 and right 20. So for person A, remember, this is 0, 0. We went up 4. If we were to count 1, 2, 3, 4, and we're going right to this point, which we know is 20 from down here. And that is simplified to 1/5. Now person B is this line that also starts at 0, 0 and goes to 40, 2. So we're going up 2 and over 40, which is going to be 1/20. So what is the relationship between these rates and the slopes? Well, the smaller the slope, the less steep the line, or the more flat the line. Or you could say the bigger the slope, the steeper the line, because 1/20 is smaller than 1/5. So the bigger the slope, the steeper the line. What does the slope tell us about each person? Well, it tells us that person A went at a faster rate because they had a steeper slope. That's what it tells us. So a steeper slope means that your rate of change is larger. Now our last example, we are going to skip. So that was a refresher on graphing equations of lines in 2 forms. We're going to be focusing a lot, though, on writing equations in point slope form that are passing through 2 points. So we're going to be doing that a lot the next couple days, but I wanted to give you guys a recap of slope intercept form and why we don't always use y equals mx plus b. Right here, you can see that that process is tedious when this one was so much faster. So thanks for watching. Make sure to like the video and subscribe.